Yes.
Okay, the code. Okay. So the aim of this workshop is to show you what we can do with generative AI in R, okay, locally. Okay, so I'm not using any internet connection. And this is a package that we have developed like 1 year ago. It's called NaileR, and we have another package which is coming on soon, which is called Trust Me. Because if you ask some kind of artificial intelligence for a question, then you need another package to check if the answer is good. But anyway, I'm going to show you what we can do with NaileR. So the main idea of NaileR, can they hear me? Okay, so the main idea of NaileR is to plug the output of FactoMineR and SensoMineR to a generative AI, okay, that I have downloaded on my computer. So first, what do I need? I need a package which is called OYAMR, okay, OYAMR. And from that package, which is on my computer, I'm going to show you how to install it. I will have all the possible large language model that I need. So in my case here, I have downloaded on my computer YAMA 3.1, okay, and YAMA 3. And that's mainly the two packages, the two large language models that I'm using. So I'm using also Mistral sometimes when I did some French stuff, but mainly it's YAMA, the model from Facebook, and Mistral, the French model. Okay, so those parameters from those large language models are already installed on my computer, and then I can connect to those parameters. So what do? I'm running basically functions from the FactoMineR and SensoMineR package, and then I'm translating those functions to some kind of prompt. And I'm going to show you an example of what we can get. Okay, I'm not saying that that's the ultimate answer to your questions, but it's just to give you an idea of what we can expect from those things. Okay, so I decided to show you the code. Okay, it's not going to be very fancy, but it's really important for you to show for me to show you the usability of the package. Okay, to see if it's hard or not to install, to play with. So here I'm going to work on QDA data. Okay, the first package I'm going to use is SensoMineR. So here I'm going to load the SensoMineR package, okay? And then I'm going to use that chocolate data set. And on that chocolate data set, it is the usual data set. You have the panelist effect, the session effect, rank, product. I have 6 products, and then I have all my sensory descriptors, okay? So you can really differentiate the factors from the sensory descriptors, because here you have continuous variables, and then you have factors, 4 factors on the very left side of my output. Okay, so from that, what can I do? I'm going to run exactly the same model, okay, that I would run if I had to run some kind of analysis of variables. So let's say, for instance, you want to see if there's a difference in terms of bitterness. Okay, so you have that sensory descriptor bitterness, and you want to explain that variability of bitterness according to the product effect and according to the panelist effect. Okay, so let's say we run a very simple model. So we have all those different scores of bitterness, and we wonder why all those scores are different. And of course, the reason why they are different is because you have different products and you have different panels, right? So all you have to do is to say to the function, okay, take those QDA data, okay, and then try to understand each one of the sensory attributes, according to the product effect and according to the panelist effect. Okay, it's only a point of view. Okay, of course we can argue on this point of view, but this is what we're doing. And then you tell the computer, okay, instead of running one by one, you're going to take all the sensory descriptors. And the first sensory descriptor starts from the column 5. Okay, remember we had 4 factors of variability, and then the 5th column was a sensory descriptor. So that's all you need, okay, to give as an input to the computer. And then by default, but this is something that you don't know, by default, the computer is not going to use the LLM first. The computer is going to generate a prompt for you. He's going to generate a prompt for you to check and to make sure that the prompt is consistent with what you want him to do, okay? With what you want the computer to do. So when I'm running this one, I get a prompt, and this is the prompt that the computer is generating for me. So you have to pay attention to this one, because I don't know if you know that, but large language model. Yeah.
Full screen so we can see.
Yeah, full screen. next generation don't need glasses, right? So anyway, but just to let you know that the prompt that the computer is generating is a structured prompt because large language model can understand HTML, can understand Markdown. Okay, so here, this is the output from the NaileQDA function. We have an introduction plus objective, we have a task, and we have the data that the computer is going to process. But those data that the computer is processing comes from the SensoMineR package. So that means that first, the computer has run all the possible analysis of variance, and then the computer has taken all the figures that are significantly different from the average and has put them into that prompt. So here you can read the by default prompt that we're using. Introduction objective. For this study, some stimuli have been evaluated by common list using a common list of perceptual or sensory attributes. Okay, those are my default options, and I'm going to show you how we can change those default options. The task, based on the results, please describe what characterizes the stimuli and what sets them apart. Then, based on these characteristics, assign each stimulus a new name. So we can see how we can make it work. Okay, so I'm going to give you sensory attributes, okay, that are supposed to define the product. And from those sensory attributes, then you're going to give me a new name for the product. And of course, here, all the products have been anonymized, okay? Chocolate 1, chocolate 2, chocolate 5, and so on and so forth. So that has been calculated by R, okay, by the analysis of variance model. It has been implemented into that prompt, okay? And what I'm telling you is that if you do structure those kind of outputs, the computer will be able to understand that. Okay, and at the end, by default, so that's my description, and that's the thing that you don't have to do. Finally, summary task at the end, provide a comparison of all the stimuli, okay, and a list of stimulus names you assigned, and their distinguishes features. So you have some kind of introduction, you have a request, and you have some kind of conclusion, and those are parameters that you can play with, okay? But by default, this is what you get, okay? And now, there's no specification of an introduction or request. Those are my parameters by default. Now, what I'm going to do is I'm going to add another parameter, which is generate is equal to true. So now that my prompt is okay, I've checked that my prompt is okay, I'm going to ask the computer to generate the answer for me, okay? And I'm going to have a look at the answer. So from this, the computer is generating three things, okay? First, a recall of the prompt. Second, the response, okay, that the generative model has taken from the prompt. And then a recall of the model that we have been used, okay? So by default, the model, as I told you, is a gamma 3, okay? And then we're going to have a look at the answer. So this is what the computer is telling you, okay? Stimulus 1, chocolate 1, characterized by high level of bitterness, cocoa flavor, astringency, and so on and so forth. And it's going to give you a description of each one of the stimuli. Okay, so it's a synthesis of the description based on the p-values that were significant. And at the end, the computer is going to give you the name of each one of the chocolate. So the guy would say, okay, for chocolate 1, I would call it rich light, intense rich flavor profile. So then it would describe the chocolate. Chocolate 2, crunchy balance, balance between textures and flavors. Chocolate 3, creamy indulgence, creamy, sweet, and indulgent profile. Chocolate 4, bold fusion, and so on and so forth. Then you got the idea. Okay, so the idea is to take the numerical informations, okay, from relatively simple routines from SensoMineR, okay, because it's only based on analysis variance. And then you take all those numerical indicators that have been supposedly significant, okay, and then you put that into the prompt. You make sure that it's well structured because the computer understands Markdown, and then you ask the computer to analyze the prompt and to answer to that question for you. That's the main idea. Okay, it's just taking information, okay, trying to put those information in a proper way okay, and then run the analysis. But of course, so remember, you can ask questions, okay? We have limitations and so on. Of course, you have many more options than that, okay? So one of the options I can talk to you about is that, okay, let's say you have many products. So if you run such kind of analysis on many products, then maybe the computer, the model won't be able to analyze all the products because of its own limitations, okay? So we have an option that says, okay, as we have like 10 products, then you can analyze the product one by one, okay? But you have to understand that those products are somehow connected, okay? But still, analyze the product one by one. So it's like not a holistic point of view from the product space, but it's more a local point of view, one by one, okay? Or we have that other option is that if you work with textual data, for instance, and then your prompt is really big, then you can sample the information, okay? So we can ask the computer, okay, now I'm going to give you some kind of percentage, and then you're going to sample all those information. And maybe if you sample the information, maybe I'm not going to have exactly the same interpretation, but then you're going to provide me many answers that I will be able to assess with that trust me package that we're working on, okay? So if you get many answers from your large language model, you still can plot all these answers and have a look at the variability of all these answers, okay? So let's say this one is an answer from an expert, and then you will be, like in a few months, able to visualize those different experts and those different sayings. Okay, so that's the first idea, and that's what we can do with the QDA function. I'm going to talk a little bit more about the maybe the options that we have implemented. So if I'm here, okay, I'm going to increase the size. I'm going to have a look at, sorry, I'm going to close this. And then I'm going to have a look at the NaileR QDA function. Okay, and then I'm going to increase, don't worry. Here I am. Okay. So, as I told you.
I have one question.
Yeah, sure.
When I read the descriptions and it says the high bitterness, does this description of high bitterness only come from the comparison within the group of tested products? Or can you like look at the number and say, okay, because all the products are relatively low?
From both, because it has run an analysis of variance model. And as it has run analysis of variance model, it's like comparing according to the average, but the average has been calculated regarding all the groups. Yes. So it's one model, like bitterness explained by product plus judge, okay? And from that model, you take the value of each one of the coefficients for each one of the products. And then you test those coefficients according to 0, means that if that coefficient is significantly different from 0, that means that whether it's positive or negative, if it's positive, then that means that this product in particular has a particularly high bitterness.
In comparison with the other products that are
in comparison with
not in comparison with the scale of
no, it's not an absolute thing. Okay. But it's exactly the same point of view as in SensoMineR first. And it's also exactly the same point of view as if you had to run a PCA. If you had to run a PCA, then your data would be centered. Okay. And then it would express exactly the same point of view as that multivariate point of view. Okay. So it would be really consistent. Okay. So just to make it quick, because the parameters that are really important, okay, are the introduction. So you can change the introduction or the request. Because here by default, we ask the computer to change the name, to give a name to the product, okay? But you could ask whatever task. And then the conclusion. So in the conclusion, if you're smart enough, you can ask the computer to work on the format of the output, okay? And if you ask the computer to work on a markdown format, you will be able to get automatically a report from Markdown. So that means that if you rerun the output, then it's going to generate a report on a PDF, on Word, on whatever, I mean, PowerPoint or whatever, okay? So last thing, you can choose the model on the computer. You can choose Gamma 3, Gamma whatever. And then, as I told you, you can change the level of significancy, okay, of your coefficients. So that means that if you want to I don't know if you know about the notion of temperature when you're working with a generative model. Okay, so the temperature is like you're going to expand, okay, the kind of the way you're going to express yourself. Okay, so the higher the temperature means that you're going to really get out of the box, of the regular expression box, I would say. And then if you change that threshold, okay, 0.5, but you switch it to 0.10, that means that you're going to take coefficients that are not really significant, but that are meaningful, okay? And then, as I told you, those two options, isolate groups, means that you can analyze product by product, or you can only use the coefficients that are significantly higher for any reason, or significantly lower, okay? So if you want to see only the positive side of your product or only the negative side, okay? Okay. Where am I? Okay, do you know where the screen?
You can see the same screen that.
Okay, but I'm looking for my, I knew that I shouldn't have done that. I knew it. On my left, right? I'm going to close this one. I'm going to. Yes, thanks. See, all generations. Okay, this is okay. Now I'm going to show you exactly what we did to make you understand what we did. So what we did is we generated that prompt here. And we ask, okay, Llama to generate an answer for us. So here you can understand exactly what has been done. And then you ask an output, okay, as a text. But the nice idea is that you can now work with prompts. And if you're not happy with that generative model and you have your own model, okay, you can use the prompt, okay, and make it run on another model. Okay, but anyway, the idea behind is just in between brackets to generate a prompt, to ask a large language model to analyze the prompt, okay, and to get an output of that. Okay, so that's the behind the scene. But we're going to use that behind the scene because we're going to tune, okay, the prompt. We're going to change the prompt a little bit. Okay, so if you, that's funny because if you run the analysis with another model, okay, then the presentation of the result is going to be slightly different, and maybe the names of the product are going to be slightly different. Okay. Anyway, so here, one way to analyze your large language model, okay, on QDA. Now, what we're going to do is that we're going to change the introduction. Okay, so I'm going to create a new, I would say, value for this parameter. Okay, and I'm going to add my introduction here. So I just have to write the introduction. 6 chocolates were measured according to a fixed list of sensory attributes, and so on and so forth. So I'm tuning my introduction right now. Okay, so I'm changing my prompt. So here, as you can see, I'm adding that new parameter here, introduction, and I'm setting that parameter to this value here. Okay, very easy. And then I'm asking the computer to generate my prompt. And as you can see here, the prompt has been modified. Okay, so I'm not using the by default values anymore. I'm changing the prompt. Okay, and by changing the prompt, okay, I'm not tuning. Tuning is not exactly the right term, but I'm increasing the quality of my answer because here, instead of stimuli, I'm going to change stimuli by chocolate, and I'm going to put into that prompt the I would say the keywords. Okay, the things that are very specific to my study. So we tried to make some kind of generic prompt that would fit for, I would say, 95% of the situations. But then once you get the prompt, you can just change it a bit. Okay, so here, so I have the answer, but I can change my prompt slightly. Okay, it's just I'm going to replace stimuli by chocolates. I'm going to replace stimulus by chocolate with an S. I'm going to replace stimuli with a capital letter by chocolates with a capital letter and so on and so forth. And then I have my final prompt. Okay, and the final prompt is this one. Instead of stimulus one, I have chocolate shop one, and so on and so forth. So I'm improving, with only 4 lines of code, my prompt. So you have the generic prompt. You can change your prompt easily. And once that you have changed your prompt, okay, all you have to do is run that new prompt with Llama 3.1 or whatever. Okay, so the NaileR function is going to give you, a rough prompt. Okay, rough prompt, but still you'll be able to use it. And then from that rough prompt, you'll be able to increase the quality of the prompt, okay, in order to get that kind of thing. Did you get the idea? Yeah, not very complicated. But anyway, it works, okay? And then you have new name here, Savannah. You have more, I would say, strange name. Mystic Savannah, it's more conceptual. See, sometimes you can ask for a conceptual name. Sometimes you can ask for names that are very close to the sensory description, okay? And so on and so forth. So now I've played. Yeah, sure.
So you're using this large language model, but
Yeah.
that the large language model is like still from the experts' answers, or is like out there, and the computer they just generating the language. Like for example, Savannah, is it like have consumers or experts they used that
No,
words?
actually, the large language model has connected to the description, and he knows that it's about chocolate. And he has to find a name regarding that description, okay, with those sensory description, and knowing that it's a chocolate, then he would provide that name.
So without
but then you could also, change a little bit the I've done that many times, but I think that you've done that as well. If I change the introduction and or the request, and you say, okay, if you as a marketing specialist, what kind of name would you provide? Then he would change also the type of name that he would get. Okay, but that's the way you use large language model. I'm not inventing anything. I'm just showing you a easy way to generate prompt that can be analyzed by large language model. Okay. See here. Now I'm going to change a bit because I want to make more conceptual. Provide a name for each chocolate in line with the chocolate target. So that means that not only am I asking the computer to provide me a name, but also I'm asking the computer to tell me, okay, to whom this chocolate should be addressed. Okay. Provide a name for each chocolate in line with the chocolate target. Okay. And then here, what I'm changing here is that I'm adding that new parameter because I have written that new request. I have my introduction, that new request, that the name of the chocolate would be in line with the chocolate target. And then I have the model and so on and so forth. Okay. And I'm going to generate only the prompt. Okay. And that's the prompt that I'm having. And here, as you can see here, the task has been changed. Task being the request. Please provide a name for each chocolate in line with the chocolate target. So that has changed. Okay. And then I'm going to generate same thing. I'm going to change a little bit chocolate by stimulus and so on and so forth. And I'm going to generate my my answer. Okay, easy. So we have seen the default parameters. Okay, we have seen that we can change the introduction, the request. I'm not going to show you how to change the conclusion, but you could change the conclusion. It's more playing with the format of the output. Okay, I want to show you some other applications than QDA. Okay, so that's why I'm trying to go a bit fast. So here, with the perfumes data that we have, same thing, it's QDA data because you have families, the session, the product, and so on and so forth. I'm going to show you roughly the same thing, okay? I'm going to play with that option. I have 12 products. So there's no way that your local generative model can play with 12 products. It's too long as a description. So that's why you have to play with the sample options, and you have to play with the isolate.groups options, meaning that the computer is going to generate a prompt for each product, not a general prompt. And then once he has a prompt for each product, he's going to run an answer for each one of the prompt, and then you're going to have a description for each one of the products. Okay. Otherwise, the computer cannot deal with that volume of information. Okay. That's the limitations of your large language model locally. Okay. But anyway, if you play like this, then you can get a prompt, and then you can get a description. Okay. So you got the idea. And what I want to show you is some other application out of the QDA data, because I think that will be interesting for you. Okay. I'm improving the prompt. I can send you the code by request, huh? Don't worry. So I can improve the prompt, okay? And then you can see that it's kind of long because you have a description for each one. And then here you have those descriptions, okay? You start from sensory descriptors, and this is the kind of output that you get, okay? This is like, you know, you're not seeing anything more than numbers themselves here, because the computer is just saying this perfume has high score for greedy heady, but this is what the analysis of variance tells you, okay, right? So you're not learning anything, but then you begin to think about what kind of synthesis you can make from that. It's enriched in anecdotal scent, target consumers, women who enjoy bold and seductive fragrances. I'm not saying that it's the truth. I'm just saying that, okay, from a kind of clean description of your product, you can get at the same time this kind of global image of the product plus the target consumers, okay? This perfume has a complex and sensual scent, target consumers, women who appreciate sophisticated and alluring fragrances, okay? And so on and so forth. And it's just, you know, to have a discussion with yourself, okay? You run your analysis variance model, it gives you that kind of output. You think about the output that the computer has provided to you. You can run that a great number of times, and then you can compare easily, okay, all these different outputs. And maybe sometimes you can find an output which is very different from the other one, okay, because the comparison of this kind of output is not that complicated. And then maybe you'll find the information that you are looking for, okay? I'm not saying that you should use large language model. I'm just saying that you can communicate with it, okay, play with it, okay, and ask what the large language model can tell you, okay? And it's not the final answer, of course. So I'm going now to change completely, because for me, QDA is description of the product. Now I'm going to introduce some kind of multivariate perspective on QDA. That means that here, I'm going to run my PCA, okay, on my average table, okay? You have your product, you have your sensory attributes, you can run the PCA. And what I'm telling to my students is that once you have run the PCA, the computer knows how to calculate the dimensions. But it's very complicated for the computer to provide a name for that dimension, right? But the magic of PCA is to give a name of the dimension, of the main dimension of variability, right? So this is what I'm going to ask the computer to do. So I'm going to ask the computer to run the PCA for me. And this is the result of my PCA, okay? And I'm going to ask the computer, okay, now that you have this result, how would you name that first dimension? Because that first dimension is a latent variable. It's a latent variable in the sense that it defines a structure on your perfumes, call it, okay? That's why it's a latent variable, okay? So we have that special function that will try to understand that structure of variability. So here, the computer will understand that on this side, you have those kind of individuals, and on the other side, you have the other kind of individuals, okay? So I'm going to show you what we're doing. So remember here, my purpose is to understand the first dimension, okay? According to that representation of the individuals and according to the representation of the variables. So what I'm going to do, this is really important, is I'm going to combine the original data set, the sensory attributes, with the dimension, okay? And I'm going to ask the computer, okay, so you have the values for that first dimension, and you have the values for the original attributes. Now, you're going to explain to me that first dimension according to the values for the original data, okay? So I'm combining here the coordinates of my individuals with my original data frame. Okay? So now that I've combined, I'm going to ask the computer, okay, now you have a dimension, you have values, but you don't know what they mean, and you have values, you know that they are sensory attributes. You have to connect those two, okay? And I'm going to ask the consumers, okay, on this consumer study, okay, 12 perfumes were evaluated, you know the story. Consumers used the same sensory attributes to evaluate the perfume. After analyzing the data, perfumes are represented on a scale. Scale means first dimension. Okay? So I'm going to ask the computer, please explain what differentiates the 12 perfumes on both sides of the scale. The scale being the first dimension again. What kind of perfumes are on the left side of the scale? What kind of perfumes are on the right side of the scale? And for that, I have that function, okay? Description of a continuous variable, okay? This is what it means. And I'm telling the computer, okay, now that you have the introduction, now that you have the request, okay, try to give me the name for that dimension, okay? So the prompt is this one. Now let's have a look at the prompt. So we have the introduction, consumer study, explain what is on the left side, what is on the right side, and then I'm using my correlation circle and my representation of the individuals. And then this is what I can get from my function. The individuals have the following characteristics on the left side. Significantly above average, and so on and so forth. Okay, so I'm combining the results from my correlation circle and also from my individual representation. And I'm providing to the computer this kind of information. Okay, and those are the information that I have on the right side of the scale. Okay, plus this is what I get. So I'm going to ask the computer to generate according to that description. Okay, so based on the data, here's what differentiates the 12 perfumes on both sides of the scale. Left side is going to give a description. Okay, floral, green notes, citrus, heavy. Right side, okay, you have another description, and the computer is going to give a name to the scale. Okay, I would suggest calling the scale the intensity scale. However, if we want a more descriptive name, and so on and so forth. Freshness versus sensuality scale. See here, freshness, okay, is here. Okay, and more heavy, maybe more sensual, Chanel, Shalimar, and so on and so forth. Okay, so anyway, by combining all those numerical indicators that you have obtained automatically, you can generate a prompt. That's the idea. And you can refine the prompt so that you can get information that you wouldn't have automatically. Of course, you can get a description of the dimension, but you cannot get easily an interpretation of that very same dimension. Okay? And what we're trying to do is to get that interpretation. Okay? So you have the idea now, okay, that the computer can work pretty well. But if you tune the introduction, you can say, okay, now I'm going to provide you the name of the products that were on the right and the name of the product that were on the left, okay? And with that name, okay, he can do even better, okay? Freshness versus elegance here, reflecting the contrast between fresh, floral, and more complex elegant scents on the right side, okay? Right side being Shalimar, Chanel numéro 5, and so on and so forth. And on the left side, Lolita Lempicka, yeah, and all the kind of easy girly stuff. Okay? So remember, QDA data, it works. Trying to find a name for a latent variable, it works as well. Okay? And the function is just, you know, taking the numerical indicators and trying to put them in a nice way for the computer to understand. Okay? Do I still have some time? Okay.
You have a 10-minute more. So
Okay, I have 10 minutes now. Oh, okay.
And then Q&A. Separately. So.
Okay. I don't know why. Okay, so this is something that I wanted to show you. And maybe I'll be able to find it here. Wait, just a second. Maybe I'm going to make a live demonstration. No? Okay, I'm going to try. Okay, you were waiting for that. Okay. I'm going to make a live demonstration on beards. Okay, so this is, yeah, I'm going to try to put it bigger. Okay, so I don't know if you can all see that data set here. So this is a data set. I've provided pictures to people. Okay, so we have those pictures. And then, so I have 8 pictures from B1 to B8. I'm going to show you the pictures. And then I have those words. So that means that for at the intersection of one row and one column, I have the number of times that a word has been used for a given picture. Okay. So what I'm going to do is I'm going to describe automatically that frequency table. Okay, so we have that function for describing the frequency table. Okay, so you can see here the introduction. A survey, I think that, yeah, I presented already that example, but it's really nice. A survey was conducted about beards, and 8 types of beards were described in the data that follows. And beards are named B1 to B8. Okay, you only have the name of the beard. Okay, please give a name to each beard and summarize what makes each beard unique. Okay, so here, the computer is going to provide you the names. Okay, the sophisticate, the charmer, but I'm going to show you the picture of the beard. Okay, the hipster lumberjack, the average Joe. Okay, the goatee geek, the perfectionist, and the old-fashioned gentleman. So you don't know anything about the pictures. You can represent yourself the beard. Okay, because you have the name. And then I'm going to show you the beard because on the sorry, 8, the bohemian. Okay, so that means that here we have analyzed that data set. So I have replaced B1, B2, B by the name. Okay, so from that, I have the new names, not B1 from B8. Okay, but I have the new names, and I'm running the analysis of variance, the Parsons analysis, whatever. So I'm running some kind of multivariate analysis. So here, see, you have sophisticate and charmer, and that goes quite well together. And here we have the hipster lumberjack, which is very, very different from the others. Okay, close to the sophisticate and charmer, you have the perfectionist. And then at the end here, very strange people. We have the goatee geek and the bohemian, right? So you have some kind of clear structure here. You have some kind of structure, okay, with the name on it. Okay, and now I'm going to show you the picture. So I don't know if you can see the picture. I think that you're a charmer, right? So you have the charmer here. You have the goatee geek here. No, but anyway, see, from those words, you see those guys here, very strange, very strange. Not that strange, but yeah. And then you have some kind of continuum, you know, of different shades of beard, maybe 50 shades of beards, whatever. But anyways, so you have that was a good one. I know when you're smiling like that, you know. But anyway, you have that very easy task, okay? Just provide 3 names, okay? And then from those names, you have that contingency table. But then in FactoMineR, we have that routine that would describe each rows, okay, by the words that are significant, okay? And then you ask the computer, okay, to provide the names. But then once you have the name, it's kind of obvious. We don't know, but that you would have named this guy that hipster lumberjack, right? You would have named this guy like the charmer. You would have named this guy like the gothic kid, whatever. Okay, but then you can rerun again and again the analysis, and it's working.
And if you do the opposite exercise, and
Sorry?
and if you do the opposite exercise based on the name you asked to generate a new
Yeah.
picture,
Yeah.
would you have
I tried.
same?
I tried, and it's working for this one. because those profiles, I know, but I think that the other way around is not. I don't know for what kind of reason. It's not exactly the same. Yeah.
Because when you generate pictures
Yeah.
using AI
Yeah.
from a single prompt, you get
I know.
using different tools, you can get.
But then this is not what we're doing, right? We have stimuli
Just to
like
check.
pictures. Yeah, just to check. If I did my homework, right? Yeah. I did my homework, and it's not working that well. But anyway, but in a real life situation, this is what you would do, I would say. I mean, you would have pictures, you would have concept, you would have pack, and then you would spread the pack, and then you would define the target, and then you would get all that work to go with, okay? And of course, you can run the other functions to understand the dimension. You can run the functions to understand each one of the row and so on and so forth. Okay, the main idea, okay, if you had to get something is that, once again, don't use it, okay? Just play with it, work with it, communicate with it, okay? But there's an easy way to communicate with a machine because there's another machine that can generate prompts for you, okay? Prompts that you can control. That's interesting, okay? Because all those numbers that you have put in the prompt, they are obtained from statistical analysis, okay? So if the statistical analysis makes sense for you, okay, then you can provide that to the machine, okay, and wait for its answer. Okay, so that's the first step. Second step, as I told you, you can generate and regenerate. And we have routines to represent the answers of the so-called experts. I mean, if you say that your large language model is an expert, okay? You want to run with Llama 3, Llama 3.1, you want to see the difference between Llama 3 and Llama 3.1 and between Mistral, then you would generate the same thing, okay? And then from that, you would get a representation. We have indicators to evaluate the consistency of those answers, okay? And to visually look at the variability of those answers, okay? So wait for that new package, which is called Trust Me, okay? And NaileR and Trust Me are going to be a very good combination to play with sensory and consumer data. Trust me. Yeah. I think I'm done.
Yeah, so then we will have a Q&A time. If you have any question and online, if you have any question, please, you can turn on your microphone or you can just type if you have any question.
Can I start with a question?
Yeah, sure.
Can you use any other statistical softwares combined with NaileR or
No, because actually in the function itself, the function is taking the routine from SensoMineR, for instance, and from FactoMineR. Okay, so the input that the function is using is first the data set, but from the data set is going to process using SensoMineR and FactoMineR, and then it's going to generate, okay, the output that I would look at if I had to explore the data. So it's exactly my point of view on the data. So you cannot use another software. I mean, it doesn't make any sense. Because the generation of the prompt is made in a SensoMineR way, I would say, okay, or in a FactoMineR way, okay. So it's one point of view. Maybe you can have some other points of view on how to generate the prompt, and especially on what kind of input you want to put in the prompt. Okay. So it's very software connected here.
Is there any risk for the data confidentiality?
No, because it's local.
It's only local and.
Yeah.
Do you have any results with the duplicates? Just to see how the.
Sure. Because here on my
I have, but
I have. On my data set. No, it's true.
Just to see if the titles, the name are We can conclude that they are similar or with
Very
the
similar.
gene.
No, but I could show you
Yes.
output from Trust Me. You want me to look at for, I have a presentation on Trust Me that I'm supposed to do today in Belgium. I mean, so I sent someone, I sent a Chinese guy doing that for me, very similar. And the guy is presenting tomorrow morning. Okay, not our conference, but I will be able to show you the slides, and you'll be able to see that sometimes the answers are very similar. So it's kind of good. It's similar in the sense that it means the something, okay, but the way to express it is different. And sometimes, but very rarely, if the structure on the data is strong, then it's not going to move a lot. Okay, it might move. It's like increasing the temperature is going to move. Okay, but if the temperature is stable, it's not going to move. Okay, and then you'll be able to pick the one that will suit you best. Yeah.
Okay. So and then you give a set of data.
Yeah.
Limited set of data.
Oh, why did you say limited set of data?
Well, you have your set of data with 12 or 6 products, so this is your data set that you implemented the tool to run the exercise. Where does your tool get the knowledge of something that is spicy, that is caramel, would be associated to something in Belgium, or where?
It's CMA 3.1. It's the model
So-
of Meta. But the model of Meta, all the
It's feeding
parameters.
itself with extra data.
No. No, it's on my computer.
It's
I have 7 gigabytes of parameters on my computer
okay.
for each one of the models. Okay, so nothing goes out.
So the tool will be more rich the more you use it.
No,
If it's the
No.
first time you use it.
it's already increasing. It's already amazingly rich, really, because it's the model that is developed by Facebook, by the guy from Facebook.
Yeah, okay.
So it's a team of I don't know how many people. It's amazingly rich.
Okay.
And I've questioned the tool for very subtle things, okay, that have nothing to do with sensory, okay, but it doesn't learn, okay, but it has been trained on like a I would say a ChatGPT 3, more or less, okay. And remember, 1 year ago, you were so happy with ChatGPT 3, so don't be picky on the food. No, but really, it's amazing. And I'm not saying, I say again, don't use it, I mean, as an answer. Just, play with it.
No,
And,
just for curiosity too.
Yeah, but it doesn't.
I have a question.
Yeah.
We are working with a lot of different products from different markets, and we have a huge database of sensory evaluation of all these products. I understand that here we have a limitation of a couple of products that can be analyzed at a time. I'm looking at like what can we do to somehow like use the database that we have and form like a background that kind of forms stable dimensions or something. I mean, this is something that you've
That's why we worked on those sample options. Actually, I'm working a lot on consumer data. So I have many consumers on my data set. And then if you do clustering and you have like 150 questions, then you have a lot of significant answers, okay, from one group together. So actually, it's not similar to your problem, but it's a lot of data that locally the computer cannot handle. So that's why we resampling, okay, according to a certain distribution, we resampling the answers to make sure that all the different things that are significantly connected to the cluster, okay, are well distributed. I mean, distributed the same way as the original distribution. Okay, so let's say you have a distribution of p-values less than 0.05, then you will try to keep that distribution of p-values, okay, and so from a distribution point of view, you would get the same thing, but maybe you'll get different meanings, but slightly different meanings. So you have that option of resampling the volume, okay, but by taking care of the way it has been connected to your original cluster. So does that answer your question?
Yeah, I think so. So you're picking the products from the sites.
Yeah, okay.
Yeah, kind of. Okay, understood.
We have a question online from Heike. She's saying, I'm still wondering where the LLM model and its use is specified in script. That is, does NaileR feed the prompt directly to an LLM, or would the end user need to paste that somewhere in one script? I noticed Llama 3.1 mentioned, but in others it's not.
Oh yeah, so by default is Yama 3,
Okay.
okay? On my computer, in the package, by default is Yama 3. But I have on my computer Yama 3.1 and I have Mistral. So you would generate a different answer if you had, yeah. But by default, you don't have to touch anything. If you're fine with Yama 3, then it's fine. Yes.
If I ask Lama to describe Chanel 4 without any data, he can probably.
Channel 4, I'm not sure.
But I
Thank you. Not even me.
Yeah. Thank you for that.
So magical trick. Now I'm fine.
The fact that we mentioned the name of the product,
Yeah.
could it influence
Yeah.
the answer?
I mean, this is what I've observed.
Okay.
So if you specify, but most of the time when you work with, formulations, okay, then you want to get a name. But then in the case where you specify the name, then you can get, slightly different answers. And he knows about this product.
Yeah.
It's not blind anymore.
Yeah, no, it's not bad, yeah.
I have a question.
Yeah.
What is your day-by-day use of such tool? Because, I mean, on the example you took, the freshness of the perfume, well, it's clear.
Oh, actually,
I don't need LLM to see that.
No,
The
you need
quality
LLM.
is really clear.
No,
and
no.
I don't see the
I don't agree.
value of the LLM.
No, you don't need LLM just to observe what are in the numbers. Okay, but to say it differently, to interpret, then you will need LLM to give the name of the latent variable. You would give an LLM to give a name of the class. So my daily use is not a sensory daily use. It's more based on consumer data. So I can show you examples on consumer when I need to interpret clusters that have been significantly linked by, I don't know how many modalities, 50 modalities. And then with 50 modalities, then you can see that, okay, boom, it's working. Yeah. So I have that example here with those consumers here, those clusters here. Okay, you have clusters of consumers. And then you have a huge questionnaire, but like, I don't know how many questions. And then you know that each group, okay, corresponds to a certain kind of answers. And if you want to summarize that, then it's, you would need that. But really in some situation, when you want to get the name, of the formulated product, and you want to make sure that the name and the target are consistent, then for reassuring, I would say I mean, it's more to convince yourself that your interpretation is kind of, good. Yeah. But actually, this is my more daily use of
And you're satisfied with it?
Yeah, I'm pretty satisfied because I confront that to sociologists and,
Yeah. And they'll be with.
Yeah. I mean, I'm satisfied with the fact that I can talk with someone. I'm alone. And then I have that friend, virtual friend that can talk with me and that can generate ideas with me. No, but really, I'm using that. And tomorrow you'll see. Tonight.
Any more question in the room? No? And then the chat online?
No, we don't have any more questions.
Okay, then perhaps we can wrap it up. But if you have some other question, we can have some networking from now on in person and people. So we will gather perhaps outside in the sun.
Yeah.
Probably. I
Yeah,
think everybody.
you have coffee, you have
Yeah?
fruits, you have outside.
So thank you for Sebastien.